Welcome to video 2 and the last video of this section 1.11 and 1.12, also known as 111 and 112. I'm going to ask you to start example 3 by seeing if you can get this process started. Remember, we're checking for continuity. Continuity requires 3 checks. Does the function value exist? Does the limit exist? Are they the same? So pause the video and see if you can kind of get going, and then turn it back on when you're ready to check your answer. I'll wait. Let's see. We're going to check step 1. Is there a y value at 3? Well, I see an equal sign, so that means I have to use this formula to figure it out. And when I use this formula, let me not put an x. Let me just substitute the 3 right now. I'll get 9 minus whatever 2 times 3 is. Well, that's 6, so 9 minus 6 is 3. There is a y value. Check. Second, does the limit exist? Well, this is a piecewise function, so I have to check the limit as x approaches 3 from the left. That's going to require me to use this. And the limit as x approaches 3 from the right, that's going to require me to use this. Oh, but I already did this one. And I already know this is 3. What does this one equal? Well, if I substitute 3 into my function, 3 squared, that's 9. 9 minus 5 is 4. Uh-oh, these are not the same. Or maybe I should put it up here. The left-sided limit and the right-sided limit are not the same. So therefore, I can say with confidence that this function is not continuous at x equals 3 because it fails the second condition. So g of x is not continuous at x equals 3 because the limit does not exist. The limit, and maybe I should just use the symbols, the limit as x approaches 3 of the function does not exist. And we're done. Okay. So knowing what continuity requires, those 3 conditions, can we build a function in order for it to be continuous, right? And so I look at example 4 and it says, can we find a value for c such that the function k of x, which is a piecewise function, is continuous for all real numbers? So now it's not just wanting me to find continuity at a specific x value. It wants me to find and make sure it's continuous everywhere. Well, I notice the 2 parts. In the top part, I have a quadratic. Quadratics on their own are always continuous, right? It's the parabola. So everything's smooth, everything's continuous, connected. When I look at the denominator, now c is going to be a number. So when I add 5 plus a number, I'm going to get a constant. And constants are always continuous as well. So if there's any issue that's going to happen, it's going to be at x equals 3 because that's where the first one stops and the second one begins. So we're going to check the continuity at x equals 3. If that continuity works, then my function is continuous for all real numbers because we already know by the very nature of the pieces that they're continuous individually on their domains. So we just need to check at this point of takeover. Okay. So I'm going to say, does k of 3 exist? Well, if I don't know because I don't know what that is, right? I know it's 5 plus c, but there's no x to plug it in. Okay, I'll come back to that. Let me check the second condition. Does the limit as x approaches 3 from the left, which is going to require me to use this, does it equal, I'm going to put a question mark on top. We're not saying that it is equal, but does it equal the limit as x approaches 3 from the right, which would require us to use that part. Oh, well, I do want to make it continuous. So if I want to make it continuous, maybe I do want to make sure that those two limits are equal, because if the left side and the right side are equal, then I can find my answer, right? All right, so I'm going to substitute a 3 wherever I see an x, not wherever I see a c, because x is approaching 3. So wherever I see an x. So 3 squared is 9, so this is going to be 9c minus, and then 2 times 3 is 6. So 9c minus 6. And I'm going to set that equal to, I'm going to substitute 3 wherever I see an x. Oh, but there is no place, so then it's just 5 plus c. And now we're going to use a little bit of algebra to get all the c's on one side, all the variables on one side, all the constants on the other. So I'm going to subtract the c over, and we're going to get 8c minus 6 equals 5. And then I'm going to add the 6 over, and I'm going to get 8c equals 11. And if I divide both sides by 8, I'm going to get that c, the magic c value that we're looking for, is 11/8. If I choose this magic number to substitute into those formulas, that's the only number that's going to make sure that my left and my right side are going towards the same place, and I have a limit that exists. And if I substitute that number into the blue part, I will have a y value, and they will be the same. The limit will equal the y value. And that's how we, I guess, create continuity. If we have a constant in our formula, we can confirm that this is a continuous function for all real numbers.